Hi everyone, it's Roger Sakach here. The purpose of this video is to demonstrate the use of my Arps decline analysis spreadsheet. The example that I'm going to walk you through is one for an oil reservoir. I also have a spreadsheet that handles gas. It's a fairly simple spreadsheet. The Arps decline analysis is really not too complex. But it is nice to have a nice working spreadsheet that can quickly run through the decline work and generate forecasts easily for both oil and gas. And I think that this spreadsheet is a good tool in order to generate those forecasts. So hang on and I will load it up and show you how it works. Now, as a reminder, there really are three types of declines that we can deal with. This is a presentation that I've put together using my decline analysis program to show you that the three types of declines are the exponential decline, which is shown here in black, and it is a straight line on a semi-log rate versus time plot. It's also a straight line on a linear rate versus cumulative production plot. There's also the harmonic decline, as shown in purple in these graphs, and it is a straight line on a semi-log rate versus cumulative production graph. And it's an upward curvature, as you can see here, on a linear rate versus cumulative production graph, and also an upward curvature on the semi-log rate versus time graph. Now in the middle is what they refer to as the hyperbolic decline, which is a case where the n value is simply something other than 0, which is the definition. An n value of 0 is the definition of an exponential decline, and an n value of 1 is the definition of a harmonic decline. So a hyperbolic decline is a decline where it has an n value of something other than that. Typically, it's considered to be somewhere between 0 and 1, but from time to time you will see the hyperbolic n exponent being actually greater than 1. So it could turn out to be quite a curved situation. Now let me introduce you to the spreadsheet itself. Here it is, and it's fairly simple. There's only 5 tabs in the spreadsheet. The first tab here, it contains the historical production. And in the green here, what we'll need to do is we'll need to fill in the dates where we have historical production history. So we fill in the dates in ascending order, whether they be monthly or daily data, and then we fill in the average rates, and it will automatically calculate the cumulative production as a function of the dates and the rates themselves. Okay, the next tab then is really the main part of the program, and what it shows is it shows, first of all, 4 graphs. First of all, there's a linear rate versus time plot. There's a semi-log rate versus time plot. There's a linear rate versus cumulative production plot. And finally, there's a semi-log rate versus cumulative production plot. Okay. Now, the reason I have 3 tabs here, which I've referred to as case 1, case 2, and case 3, this allows one to put together various scenarios, which can then be finally put together and compared in this final tab, which we call the composite forecasts. And so here it is here. So this series of plots includes 3 forecasts, one of which came from that case 1 tab. This one in the blue came from the case 2 tab, and the one in the purple came from the case 3 tab. So we can put together various scenarios of decline trends, you might look at it as one might be a proven developed producing case, another proved plus probable case, and finally the third might be a proved plus probable plus possible case. Or alternatively, we may just have different development scenarios that may be included into the various declines. At the end of the day, then we can just compare them all on these plots, and it shows the final forecasts. So let's take a look at case 1 here. Really, the first step in doing decline analysis, the way I like to do things, is I like to break it sort of into 2 different pieces. First, I'll call it a history matching phase, and then the second is what I would call sort of a forecasting phase. What I'm showing you here is more of a history matching phase, where I'm attempting to match the historical production, which we had filled in this first tab, and that appears in red, these red dotted points here. There's a little bit of scatter in the data, as you can see, and we're attempting to match that data. Now, actually, what I like to do when I'm doing any type of reserves work, I like to start with the most likely scenario, which is the proved plus probable scenario. So let's jump to case 2 here, and I'll show you how the history matching part has been set up. First of all, we're dealing with oil reservoir here, and we feel that the original oil in place is around 50 million barrels. And as a first pass or medium case estimation, we feel a 25% recovery factor is appropriate. So that gives us ultimate recoverable reserves, in this case of about 12.5 million barrels. Okay, the initial rate when this field came on, as you can see, was 5,000 barrels a day. There it is here, and you can see it here on the semi-log plot of 5,000 barrels a day, and also in the rate versus cumulative plot, 5,000 barrels a day. So which is exactly why I've got 5,000 barrels a day put in here for the initial rate, and a reasonable estimate of the abandonment rate is 200 barrels a day. And we're using an N value, in this case, of 0.6. And that's been played around with a little bit in order to give us a reasonable match. We could come in here and we could put in 0.2, and it would, you can see that we're not very close to matching the actual historical data at all. So I've just played around with it until I was able to get a match. There's 0.5, there's 0.6. It seems to match quite well. So that's a reasonable good, what I would call a history match at that level. And by the way, in this history matching phase that we're on right now, what I have here is I've entered where it says the cumulative oil is entered manually. I've typed in yes, which is to say that I want to start my forecast right back in day 1 when our cumulative oil was 0. When we get to the next step and start forecasting beyond that, I will type in no here, and then it will update this cumulative oil with the actual cumulative oil that it will read from this historical oil production. But for this first pass, just history matching, I want to start my forecast up here so I can see how well it overlies that historical data. And so now that we've completed the history matching component, let's step onto the next phase, which is the forecasting side of things. So as you can see from these plots, my forecasts in black, I'm on the case 2 tab, start at when production first came on. So what I want to do at this point is I want to start the forecasting here at this point, which is just at the end of the historical production. So I want to begin here, and I want to begin our forecast here rather than right at the start. That was all useful for the history matching side of things, but now I want to start stepping out and going beyond. Let's go back to the historical oil production tab here, and here it is. Here again we have dates, we've got average rates, and if we scroll down to the bottom, we'll note that the last date where historical production is up to is December 1st, 2014. And this value here is the average rate between those two dates. Okay, so again, December 1st, 2014 is when our production data goes up to. So if I come back here and if I type in December 1, 2014 here, that's then going to allow us to begin our forecast at this date rather than the previous date when production began. So now you can see by doing that, the black curve has now slid over. However, you can see on the cumulative curve, we're still starting at a cumulative volume of 0. So in order to fix that, what we need to do is we need to come into this part here where it says cumulative oil entered manually, which allowed us to type in that 0 here. Now what I'm going to do is I'm going to simply type in no, and it will read the cumulative oil as the maximum cumulative volume that appears on that historical production tab. So that now has caused that forecast to slide over here also. So we're okay on the time basis and we're okay on the cumulative production basis. The only thing that we're out now is on the initial rate. We can see that we have an initial rate of 5,000 barrels a day, which is correct at initial conditions, but it's not correct for today. Let's quickly go back and take another look at this historical production tab. And if we go down the average rate column here, we can see again that the rates are fluctuating somewhat on us, but on average, maybe we're should be starting off our forecast at around, let's say for the heck of it, say 2,000 barrels a day and see how that looks. So I'm going to come in here and I'm going to type in 2,000 barrels a day, and you'll see these lines shift accordingly. Now it's looking pretty close, but I would say maybe not close enough. Maybe that 2,000 is a little bit too high. You can see we're beginning our forecast at the higher end of our scattered red point data. So maybe let's try 1,900 barrels a day and see what that does. And that seems to make more sense. That's a good start of our forecast. And really what we've done at this point, to summarize, is we've, through that history matching phase, we have determined what some of these, the best parameters would be in order to match the historical production. And now what we've accomplished in doing is we've started out our production forecast at a reasonable level, and it's making use of those same parameters which we had determined earlier to generate forecasts going out. So let's do that for cases 1 and cases 3 also. So I'm just going to come in here, December 1, 2014, and that's going to be a no, and that's going to be that same 1,900 barrels a day. And we'll do the same here, December 1, 2014. This will be no, and this will be 1,900 barrels a day. So now that we've got all three cases put together, we should be able to go to this composite plot, and it shows a nice range of projections, sort of a proved case in black, a proved plus probable case in blue, and a proved plus probable plus possible case in purple. They're all starting out at reasonable rates. They all have different ranges of n values or levels of curvature, and they project out different ultimate recoverable reserves for the different scenarios. So now that we have those first pass forecasts completed, we have the ability now to consider other things that may happen in our field. For example, maybe these wells are flowing wells, and maybe at some point we want to put artificial lift in place. Or alternatively, maybe at some point in the future we want to do a stimulation and reduce the skin factor or the damage in these wells, both of which, whether it be the artificial lift scenario or the stimulation scenario, may result in increased rates at some point in the future. And it also may result in increased reserves. So how do we handle that scenario in the spreadsheet? We would do that like this. Let's go back to our case 2 scenario. And let's say we have plans to do a stimulation let's say on January 1st, 2019. So what we would do is we type in the name of whatever change that occurs. So we've labeled that stimulation. Our condition change will be January 1st, 2019. And it will result in incremental oil production rate of 500 barrels a day. It will add 2 million barrels of reserves to our previous estimate of 12.5 million barrels, which will give us a total ultimate recoverable reserves of 14.5 million barrels. And we're just simply going to use the same N value which we had previously used. And at this time, there's no reason to change that abandonment rate. Okay, so that's the condition change that we're going to work with. And in order to make it active, we just simply need to type in yes here. And that results in that change in the future. Now, what we can see in these graphs is at this time, we have the original forecast in black, and then it's overlain with the blue, which is our condition change. And although that condition change occurs, our original forecast continues to follow through. There may be times when you want to do that, or at times when you want to get rid of the original forecast. If we want to get rid of it, we just have to come down here to where it says truncate previous forecast, type in yes, and it simply gets rid of it. Okay. We can do similar things. I've already got it set up in the case 1 here, where we've got similar situation, 500 barrel a day increase, rather than 2 million barrels, which we had in the case 2. We're going to go with a little bit less of incremental reserves of 1.5 million barrels only, and we're going to use the same N value as before. So I'm going to come in here and I'm going to type yes, and that also will change that. Again, we have the option of getting rid of truncating that previous forecast at that condition change point. So that looks fine. And then finally, let's go over to the case 3 scenario, which I also have set up. Now this one, I've got 2.5 million barrels of incremental reserves and incremental production rate of 800 barrels a day. But the other thing that I've changed too is I've decided that maybe in this scenario, rather than our condition change happening in January 1st, 2019, I'm going to accelerate it a little bit to January 21st, 2018. Okay, so I'm going to come up here and maybe for the heck of it, we'll just set that up. And so there you go. There are our 3 forecasts completed. And now we can come to the composite forecast, and it will now change the previous ones, which were fairly simple, to something a little more complex, where we have initial production declines coming down, and then at certain times an incremental rate, and those resulting in incremental reserves. All right. And by the way, if you want to see the actual numbers which result from the forecasts, then what you can do is you can come to the individual tabs. And let's say we're interested in seeing the actual numbers for the proofless probable case, which is case 2. If you come just to the right of forecast plots, you'll see a nice summary here. So it shows the dates. Again, these are presented on a monthly basis as shown by the 2 here. So it shows the date. It shows the oil rate, which is occurring exactly at that date. And it shows the average oil rate, which occurs between the 2 dates. So for example, the 1900 barrels a day is exactly at December 1st, 2014, whereas the 1888 barrels a day is the average rate between these 2 times. So in other words, it's the average rate for December. And the cumulative oil volume is the cumulative oil volume at that particular date there. One thing I would mention is we can come in here and we could actually quite easily generate it on a daily basis. So if I typed in a 1 here, it would just change some of the scaling of how the plots look, but the actual forecasts themselves are unchanged. It's just that we're presenting the information now on a daily basis. There's December 1st, there's December 2nd, and you can see that the production rates are now dropping still, but much less than the monthly data showed. And finally, we could come in here and type in a 3, and it would present the information on a yearly basis, in which case then we're starting December 1st, 2014, and then it just beyond that, it starts at the beginning of each year. And so these are obviously then the average yearly rates that we're showing in the average oil production. And again, these are the oil rates at exactly those particular dates and time. And a couple other things before we close it off. I wanted to mention that this same spreadsheet, or a very similar spreadsheet, exists for gas. It works in the same manner. It's available. And if you do want a copy of the spreadsheets, you can go to www.sakachassociates.com. And I'll just type that in here so you can see the way it looks. Okay. So that's where you would go if you want to gain access to a copy of those spreadsheets. Thanks.